We are presenting the article, Mapping Activities and Inputs of Modular Construction with Steel 3D Modules in Brazil. We are Gabriela and Ricardo.
The construction industry consistently presents low productivity and lack of sustainability. In this context, off-site construction emerges as an alternative to improve the performance of the construction industry, being faster and more efficient. In this kind of construction, activities are carried out off-site in a controlled factory. Talking about off-site construction, one of the most efficient practices of this approach is modular construction. Modular construction is where different parts of a building are designed, prefabricated, and assembled as modules. This can be carried out with a higher degree of finishing in a factory environment, and only a few assembly and finishing activities need to be conducted at the construction site. On-site activities represent only 10 to 15% of the total activities, including foundations, finishings, and connection between modules. But what about the modules? A module is a functional unit prefabricated off-site related to a part of a product that allows product compositions through combination. In some countries, such as Brazil, the advance of the COVID-19 pandemic made modular construction popular due to its advantages, mainly in the construction of emergency hospitals. So, aiming to discuss the process of modular construction and its supply chain, the purpose of this paper is to map the process involved in modular construction with steel 3D modules, including the operation and inputs based on a multiple case study performed in Brazil. Talking about what we found in literature, modular construction has some phases. This comprises design, pre-construction, construction, and post-construction. The first phase includes design and permissions. Pre-construction comprises the planning and scheduling of activities, engineering, production of the modules, site preparation, and also foundations. The construction phase includes stages associated with managing the delivery, transport, lifting, on-site assembly of the modules and their installation, where modules are connected and finished with adjacent units. Finally, the post-construction phase includes occupation, monitoring, and possible reconfiguration. In modular construction, there are two types of them, three-dimensional and two-dimensional modules. Specifically, beams, panels, finishing elements are used to manufacture 3D modules on production lines, while frames, walls, windows, and doors are used for building two-dimensional facade panels. Nevertheless, in this paper, 2D elements are called 2D modules only when they are produced off-site and transported to the site almost finished. So, the focus of this study was to investigate modular buildings comprised mainly of steel 3D modules, and the main parts are characterized below. The structural function of the steel 3D modules is performed by the foundation structure and by the steel structure. In the envelope, there are closing panels such as slabs, external walls, and the roof. Within the services, there is the execution of mechanical, electrical, and plumbing installations, and the internal works with the execution of internal walls, finishes, and coatings. About the research methods, the main questions addressed in this study were: how is a modular construction with the steel 3D modules performed? What activities are carried out off-site? And what are the inputs of the process? The search for the answers began with examining bibliographical sources, mainly scientific publications related to modular construction, which contributed to identifying the phases of modular construction. However, these do not provide sufficient details related to the activities and inputs applied in each phase. Therefore, to answer these questions, a qualitative multiple case study in 3 companies was performed with comparative analysis.
We studied 6 different cases: schools, houses, office building, and a hospital. For each one of them, the occurrence of theoretical phases was verified, confirming them as modular construction. On comparing these cases, the phase with the most particularities was the production of the modules. This includes activities performed or inputs related to one case that were not repeated in another. The main difference are the materials. There are also differences between the activities performed. This is because foundations, dimensions, and especially materials involved change according to factors such as design, schedule, or cost. The number of models needed for production of the office building requires more detailed delivery management. The hospital was built to serve COVID-19 patients, and all the planning and execution was focused on one main factor, speed. On the other hand, the 6 case study had a steel structure. Only the assembly, installation, and other finishes took place at the construction site. In addition, all cases presented the phase design, production, transport, assembly, and installation, meaning that the sequence of activities was consistent among the companies, but there was no uniformity regarding the product. After comparing cases, we are able to map the process, represented below. It is divided into 6 stages. 1. Design and planning. 2. Substructure execution. 3. Production of the models. 4. Transport. 5. Assembly. And 6. Installation. It shows activities, inspection, and inputs. The production stage involves the greatest number of activities and inputs and occurs simultaneously with the execution of foundations. Company A generally chooses to use W or C profiles. Company B prefers to use folded sheets of steel, while Company C uses sliced steel profiles. This means that the structures are produced from different inputs to complete a 3D model. Inspections are then performed to check plumbing, leveling, and squares. Next step include the execution of the envelope. For slabs, Company A and C use wall panels, while Company B uses prefabricated 2D models in reinforced concrete. Despite the different inputs used for the production, this stage always ends with a 3D model being enveloped. Almost completed models are commonly transported by roads, trucks, and sometimes by waterways, ships, to the construction site. This stage ends with the receipt of the models. The assembly stage begins after receiving the models at the construction site. The lifting activity is usually performed by cranes or boom trucks. Upon lifting, the models are positioned and leveled. Once the positioning is completed, the modular units are consolidated, forming a modular system, that is, a composition of models. Installation includes connecting facilities and performing finishing activities between models. Electrical installations have connectors and it arrives at the construction site ready for connection between models and just need to be plugged in. The hydrosanitary facilities, on the other hand, have cap plugs to be connected to the construction site facilities. The joint between models also receive thermal, acoustic, and waterproofing treatments, which also vary according to the company. After the joints between models have been treated and the model is watertight, to complete the installation, the finishing activities are performed. In addition, repairs are carried out to fix any damage caused during transportation, such as scratched paintwork or cracks in the plaster. Finally, all activities performed on the construction site are checked. So, we can observe that the process involving modular construction with steel 3D models are similar to the theory. Uniformity among the process of companies' studies was identified. However, variations in terms of the product were observed too, due to customization of the models, resulting in different products with different inputs. This means that different companies perform almost the same on-site and off-site operations with variations of inputs. As a result of the study, the process, its operations, and inputs were mapped into a flowchart based on 6 stages. 1. Design and planning. 2. Substructure execution. 3. Production of the models. 4. Transport. 5. Assembly. And 6. Installation. This mapping reveals that all 3 companies studied perform similar activities to ones in the literature. Thus, it shows uniformity in activities involved in the process. Nonetheless, with regard to the models, variations were observed in their production, since the models are customized in each case. This is because companies use different inputs in the process. The flowchart shows how this kind of construction is performed. This will be useful to address planning, control, and supply chain management issues. In addition, it helps the reproduction and improvement of the process and its implementation. Thank you.